Okay, so I'll give you a brief introduction of what I want to talk about, but most of what we're going to do is just going to be a demo. I'm going to show you how to use Git and GitHub. Um, and first of all, what is it and what we're trying to achieve? So problem number one is version control. Okay. So imagine this is the classical picture of you trying to work on something, right? You have a final doc, and then as time goes on, the word final gets repeated many times, right? And that's a way to do version control, I guess. You just keep old files and start stacking them. Uh, but preferably we want something that can actually tell us. So if you have two versions of a file, it would be nice to be able to see exactly where the differences are, right? So that's the first problem that the tool that I'm talking about today, Git, really tackles. The second problem is collaboration, right? Because very often, and especially, in this series, we focused on computational work. And in computational work, not necessarily just like Paul and I do, which is theoretical modeling, but anyone that works with data analysis, anyone that works with any type of data mining or producing plots or anything I think that covers most people. You would end up having to write some routine on a computer to go there, treat that data, right? And a lot of times, especially some journals, not all in it's not common in chemistry, I don't think, but in many disciplines, they want you to publish that code because it's a matter of reproducibility, right? So beyond just being able to collaborate with others, you want to be able to put your code out there, put your work out there so people can use it for whatever they want. So that's one aspect. And the collaboration, again, is what if you have multiple coworkers working on the same file, right? So you want a system that will allow you to not, first of all, have terrible conflicts, right? Because what if you're working on the same part that someone else is working, right? And as the project gets really big, this becomes a real issue. Okay, and these are some options. In fact, when I started my postdoc, um, the group that I joined, they would do everything on OneDrive. So they would write a bunch of code and put in OneDrive. So I got there and I said, "What are we, amateurs? No, this would not go." Okay, so I created the GitHub for the group. I taught them how to use GitHub, and now they're on the right track, right? Because this is not ideal in many ways. This is a good way to share PDFs and a bunch of just dump files there, right? But have a research grade a code, for example, no, it's not good, right? So the protagonist of the story today is really Git. Git is the underlying software that is basically a version control a routine, a version control software. Okay, so most of what I'm going to do is going to be Git. If you want to follow along, you probably have Git already on your computer. You can just go open the terminal and type git dash dash version. I'll do this in just a second, and you see that you should have Git already in all platforms. The PowerShell in Windows, Mac certainly has it, Linux certainly has it. Okay, and then towards the end, this is just to define Git is a distributed version control system that tracks changes in files over time. And allows you to work safely, so you won't destroy your files and allows you to collaborate. Now, a final piece, which I didn't write anything here because I got lazy, sorry, but the final piece of the work here is GitHub, right? And I want to differentiate because Git and GitHub are actually different things that very often get bundled together just because GitHub, so Git is a version control system, allows you to control modifications in the file, and then GitHub will allow you to host that code, for example, somewhere. Okay, so GitHub is like think about it being the cloud. the web that will host your work. So this is ultimately where you're going to put, for example, work that you use to treat some data or to produce some plots or to run some calculations. And you're going to share this, and people are going to be able to go there, see it, download, use for their research, and hopefully get you some citations out of it, right? Okay, so that's the end of my presentation.
I use GitHub.
You do. There you go.
Good job.
Yeah, so let me see if I can zoom a little bit. Can you see my screen? Okay. Clear. Oh, this is, I'm gonna bring this down a little bit so we can see. Okay, let me hide this. All right. Okay. I think that's pretty visible, right? Should I zoom in a little more?
That looks good.
No, that's fine.
Okay. Okay, so first of all, let's see, do I have Git? So you go Git version. There you go. I do have Git. By the way, I'm using the PowerShell. But because I'm on Windows,
Thank you.
but it should again work in any system. All right. So let's say I have a research project. I need to start writing some code. All right. First step, I'm going to create a folder. So this is just standard commands on term. I don't know. Have we ever had a Linux?
That was the first one.
Yeah, the first one. There you go.
Kate
So
did it. Kate did it.
yeah, so we're gonna do make a dir, make a directory, and we're going to go ahead and you can name it whatever you want for your project. I'm gonna do a Git demo. Okay, there we go. I created a folder. Now I'm gonna enter the folder. I'm there. There's nothing in here. LS shows me what's inside. There's nothing inside. All right. So now I'm going to go ahead and try to use one of the main, what I consider to be one of the main commands in Git, which is git status, which basically will tell you what's the situation here. What is the situation of this folder? Let's see what happens. Okay. It did not like that, right? Why it didn't like that? Because Git is pretty much telling me I have never seen this folder in my entire life, right? So that's the first lesson. We need to tell Git, please keep track of this folder. It won't keep track of all your system. Okay. You must tell Git, hey, this folder right here, I want you to keep track of it. And how do we do this? It's a command called git init. Init, like a British person, you know. All right. So you go ahead and that would be initialize your empty Git repository. There we go. So now Git is keeping track of my folder. Okay. Okay, so if we try again Git status, now we have some actual information, right? And those are all three useful informations that we hopefully at the end of this workshop, you're going to be able to understand what these three pieces of information mean. The first one, on branch master. Okay, we're going to talk about branches. Branches are just different sort of timelines of your project, okay? And we're on the main one because once we created the folder, we created one branch, which is the very first one we start working. So you can really think about Git as being a tree, right? And right now we just have one sort of main trunk, and that's master, and that's where we are. No commits. I'll talk about commits. Commits are basically going to be the snapshots. They're really the basic unit of Git. The commit is a snapshot of your project, okay? And nothing to commit, meaning there's no modifications, there's nothing in this project, which makes sense because we just created, right? So I'm gonna go ahead and create a file. Now, actually, I think I'm gonna, so now that I created a folder, I think I'm gonna go and move to VS Code, just because we have a better interface that we're gonna be able to do. So you can do everything on a terminal, but you need something to visualize the files and modify it. And since we've been actively avoiding Vim, I am gonna which is a hardcore way to do it. I open here VS Code. Look, my folders. I'm already on the folder. right? I can press Control tilde to open the terminal. So now here it's nice because we have three things on VS Code, and that's the reason people use VS Code, right? You can have the terminal down here where I'm going to write my commands. The files, I'm going to visualize the files up here, and here you're going to have the file structure, the folder structure on this side. So we're going to create our first file. Right here, I'm going to click on this button right here, new file, okay? And I'm going to name it myfile.py. There you go. So you see, it created a new file. I have here an empty slate that I can start working. Okay, so I'm going to do a print statement. So let's write some Python code. Hello, lunch and learn. All right, I'm going to save that file. Okay, on the terminal right here, so if I do an ls, you can see ls, we're just going to list everything that I have here because I'm in the same folder. So I have my file. Okay, I created my code. And of course, in your real work, you're going to write whatever research code you need. You're going to be able to run and test that. So let's run my file right here. I get a hello, which is the point. So I got my code working. That's okay, got my code working. I'm happy with it, but is Git keeping track of this? Not really. Let's see what's going on in Git. So we're going to do a Git status. We do a Git status right here. How do I zoom in here? You know?
I don't know.
If I do this,
Oh, that works.
That works, right?
That works.
Let me close the, yeah, that works. Perfect. Okay. All right. Okay. Now, so when I do Git status, again, the same information right here on branch master, no commits yet, but now he detected, hey, there's something here new. And he's telling me this is untracked. So Git will not save the files by default, but he detected that this is new, it's modified, it's never been here before. So it's telling me this is a new thing, but I have to go here and tell Git explicitly, hey, I want you to add this to the list of modifications that I'm going to accept. So I'm going to do git add my file. Now, I didn't really save the modification yet. The language here is that we staged the modification. So meaning that now Git to say, hey, okay, understood, this modification here is important. I'm going to keep it here until you tell me to actually save it. So you just staged the modification. So if you do a git status again, you get a new file. Look, it's green. So it's color-coded telling you, hey, yes, I'm ready to save that. And by save, I mean, let's create a commit, okay? A commit is a snapshot of your project, okay? So I'm going to go ahead and git commit. And it's the name really implies, I want this to be a milestone of the project. And milestone is a big name, and maybe we shouldn't say this because you should commit often, right? You should create several of these snapshots. Right? But once you don't have to have a lot in terms of best practice. Once you get like one thing done, commit. Okay, such as your commits are like baby steps in developing something big and complex. Okay, you don't have to, code for a week and then do a commit. No. You should be doing that daily if you're working on code. Okay. All right. So this is so you want to do this commit -m, which means message. Okay. And then you want to write out some descriptive message that will help you later understand what you've done here. So here I'm going to write just my first file. And there you go. We committed. We created the first save point, first checkpoint of the project. Okay. All right. And actually, if you try to do it and you never use Git, you might get an error. Because Git might tell you, first, before you commit, I need to know who you are. Because every commit needs authorship. Okay, because Git keeps track of changes and who made the change, which again becomes important when you're collaborating, right? So if you do run into that problem, you would have to do something like this: git config global. It's one way to do it, of course. And then you do user name, and then you give your name. So I don't know. I guess for username, I just use my username from GitHub to make sure everything matches. So that's what I would write there. And then you do the same thing for email. Email. And then again, I put the email, my personal email that I use for GitHub. Okay, I use my personal email. You want to use your personal email for GitHub because, you know, you can always get fired. So you want to make sure you're not going to lose access to everything you've done. All right, so if you got that error, it was just a matter of setting git config. Okay, and now let's let's modify something. So let's go back here to the file and print. This is my second version. Okay, so I'm saving that. That's been saved. So if I do now git status, there we go. So see, it detected that's been modified, but then again, it will not save this automatically for you. You must have the agency of saving things. Okay, it's saved on your local computer, but Git will not absorb that by default. So we're gonna do well, before, let's create another file just to make something more interesting here. I'll try to get rid of this. Right here, new file. I'm trying new.py. So I have yet another file. And I'll just keep it simple here because this is not about coding. So the code keeps growing. Okay. All right. So then again, git status. What do we get? We have one modified file and one new file that's not being tracked. So now I want to add everything. So I'm going to do a git add, and you can just type the name of the files and then type the other. Or if you're sure what you're doing and you want to add everything, you can just git add dot, and that should add everything. Okay, now you do a git status. Look, it's green, it's staged. Remember, it's not saved, it's staged. Okay, once it's staged, now I can make my second commit. Okay. So I am gonna go for following git status, git commit. Let's go. Git commit my second commit. There we go. So if you, after that, if you do git status again, you see that there's nothing to commit. It's everything is clean, everything. So by the end of the day, you want to leave your work, and this must be the message you read, right? Unless there's something really broken in your code, which sometimes happens when you leave Friday and everything is a mess. Okay, so there's another useful command will be git log. Git log will tell you, will give you a story, and this is chronological order, reverse chronological order. So this is the latest commit right here. So it's telling you the commit has a code, okay, and the author, so it's me, the date right now. So see, it really keeps nicely a log of all the modifications that were made here. So this is the second commit that I just did, and this is the first commit. And it keeps going. Now press Q to exit that, and that was the log. Okay. Now, okay, so I think this is like the bread and butter, right? You make modifications, you add to Git, and you git commit. But so far, first of all, it's all local. So we're gonna get on connecting that to the cloud, right? But then another important thing is that which happens. What if you get sloppy and you break something? So let's break something. So let's say I forget what year it is and I do a print without parentheses, like it used to be in Python 2. Okay, so I save that and then I'm all happy. I'm gonna run my new code right here. Ah, I broke it. So happens, right? I broke. And typically you can go there and try to figure out what has changed.
Sorry.
Yeah.
Just my OCD, but there's a number that keeps popping up on the left.
Oh, do you want me to tell you about this? This is
Are you
what
planning to?
yeah, this is the Git interface of VS Code. So if you click on it, it actually shows you a visual of what I'm talking about. So you see these dots, they're the commits that we made, all right? And it will also tell you right here the changes. So right now we've changed this, but it's not staged. So you can actually stage and commit this. I'll do this in a minute because I don't want to commit because I know this is a mistake. So I'm not going to commit this yet. But you can commit here, write your message, and commit. So everything that I did on a terminal right here, you can do here. And maybe you probably should. I've learned everything on a terminal, so I'm kind of, for me, that's the natural way to do it. But you can do it right here, no problem. Okay, everything that I said has a graphical interface. That's the good thing about VS Code. And also, look how nice. You can click here and see. So this is the commit. And if I click on new, look, it will show me what the code was. You see? So this is my current code right here. Can I close this somehow?
You can hide it.
Hide Winnipeg, is that it?
Yep. And then move away from it.
Hide name.
No. Just click away from it, and it will automatically disappear. It should. Oh, hide floating.
There we go. Yeah, so this is the current code. But if I look here in the timeline and I click right here, it will show me, oh, this is the my file, this is the new file. Look what it was. So that's one way you can see where you messed up. But if you know you messed up and you need to restore the original version, you can do a git restore. And then we type the name, which was the new file, right? Let's go back here to new.py. Okay, let's go back here. There you go. The code has been restored. So you broke the code, but you can always restore to the previous commit. So it looks at what you've done and say, we can forget that. We're just going to go to the previous version that was saved. Okay. Okay, but sometimes you may break it for real. Like you can get real sloppy. So let's break this again. I'm just gonna drop a parenthesis, and then drop a parenthesis. And of course, if you try to run, it will give you a problem because the parenthesis was never closed. But I broke the code again. But let's say that this time around I wasn't very careful at all. So I actually commit the mistake, right? So let's use the interface here to commit, just to show this interface. So right here, it tells me the modification. That's why it has this bubble here, which is kind of annoying. It looks like notification, right? Yeah. So I'm gonna stage, now it's staged, and then I'm gonna write a bad commit. Okay, and then I'm gonna go ahead and commit that. Look, it should change down here. There you go. So now we have 1, 2, 3 commits. So my bad commit right here, it shows me, if I click on the commit, it shows me, look, I deleted that line and I included this line. So it shows me exactly the modification that was done. Okay. Color coded. All right. How can I save things now? Can I do a git restore? Let's see, git restore new. Go here. No, still broken. Why? Because it's restoring to the version that was committed, right? So now there's a harder way to do it. So on my, again, just for completeness, we can look at the git commit, and you can see the latest commit is the bad commit, and then before that, my second commit. Okay, what I want to do is say, this was a big mistake. I wish I had never done it. So how can we just forget about this commit and go back to this one? Okay. How you're going to do this is a git revert. Okay. It's another command called git revert. All right. And I believe it's just this. So this is basically gonna revert the latest.
It's just this, but you can also
Just
just
this.
put in the hash.
Yeah, you mean this?
Yeah.
Yeah, you can just do this directly, right? But the way I'm doing is just that it's the latest, right? The one that I'm currently pointing at, which is the one that I'm currently sitting on. Then you can just do this. If you need to get, more in the weeds, you'd have to actually specify the ID for that. All right. So now it wants you to put a message here. Okay, I'm happy with this message. I think that's descriptive enough. Revert that commit. So I'm just gonna close this and save, and that is saved. So if we look here, it actually adds another commit. So it doesn't delete this. It's like your history, you need to be proud of it. Okay. The history stays here, but it adds a commit reverting that commit. Okay. So look, we're getting a lot here. All right. So and of course, this is basically git log, but you can always do a git log here and see exactly that. So revert bad commit, and then down here you'd have the actual bad commit, and then the other commits that we did. All right. Okay. So clearly, sometimes the business here get a little risky. So there are safe ways to make modifications to code, and that should be the main way you want to do this is through branching. So remember, I told you you have a main branch. So you want to develop something new, and you don't want it to, especially if there are other people working on the same code, you don't want conflicts. So the best way is create branch off the main, and you can work safely there. And if you break everything there, you can always delete the branch. Okay. So how I'm going to create here, there are many ways to do it. Git is a very old code, so there's many ways to do the same thing. The way I found was git switch, but there, you can also do git branch. I think git switch is because git branch also gives you information about branch. So I think because git branch has multiple usages, git switch is sort of a safer way to not get confused. So what I'm saying is that I want to git switch to a different branch. -C, meaning I want you to create this new branch. It doesn't exist. So before I do this, let me do git branch. There's one branch, master. And the star means I'm here. Okay, so I'm going to do a git switch, create, and then I am going to new feature. There you go. So I'm already switched to the new branch, and it exists. So if I type here branch, okay, git branch, master, new feature. So I'm here in the new feature. Okay, so let's modify something in the new feature. I will come here in a new file, or yeah, new.py, and I'm gonna add something to my new feature. Like now you see me. Okay. All right. So I save. So I'm gonna go ahead and git git status. See, the new is modified. So it's the same workflow. You're gonna get tired of doing this. Git add. Okay, git commit. So new feature. Okay, it's that, right? Nothing, so I'm gonna Python the new dot py, and you see that we see that sentence, all right? All right, well, what if I go back, git switch master? Okay, and I'm gonna do a print. See, that line is not here. Okay, so let's go. This is the up here, you can see the code up there. That line is not there. That line only exists on the second branch. Okay, so you can do all the modifications you want in that branch. Once you're happy and you're like, this is good, you can put things in main. So the good practice really is to keep main the working solid branch that everything has been tested. We're all sure of the work. Once you achieve that level on your branch, you can merge back into, and that's what we're gonna do now. I want this to port back to master. So I'm in master. Let me get branch here. Make sure I'm on master. Yeah. And now I will. If you haven't sure, there's also this command. Show current, which I'm just going to mention this, which is kind of the same thing, but it's only going to tell you the branch you're on. And now, okay, we go git merge to bring the new features on the new branch back to master. So what we're going to say is merge new feature. So what Git's going to understand is, okay, I'm here on master. I want you to go to new feature, grab it, and merge back with where I am.
Can you also add master after?
I think you can, but you don't have to. Well, let's see. Let's see.
The enemy.
Yeah, so it worked. Yeah, I think you can do a slash. There's so many ways to do the same thing in Git, but that's the way I kind of learned. So you just go to the branch you want, and then you fetch what you want and bring to that. So that requires you to do a Git switch. Okay. All right. So that is the merge. So do a Git branch here. We're on master, and let's run the Python. There we go. So we brought that new feature onto master branch. Okay.
It's still on the other branch?
It's still the other branch exists independently. Yeah. So
Does it show on the visual thing? I don't remember. The other branch.
The other branch,
doesn't
you
show.
gotta select here, I think. I don't know,
So
actually.
what happens if we select both?
Good question. Let's see. Right here, master.
Okay. Oh. Did you click OK?
Oh, did I not? Okay, let's see.
Doesn't show anything. Okay.
No, well, let's see. Can you change here? I don't know. Again, I don't use the visual interface very much.
All right.
Um,
Never mind.
yep.
Just curious.
Where am I? Master. Git switch new feature. Let's see. It's not gonna change. It's not gonna change anything here, will it?
It changed.
Yeah,
changed,
okay,
yeah.
so we went. So I don't know how to do it here, but you do it in terminal and you can switch in our show. But of course, right now they're identical, right? They're the same thing. And if you're done with it and you want to be tidy, you can always delete the branch. So I'm going to do this right now. Git branch -d for deleting and new feature.
You're on it.
Oh, am I? Yeah, okay. So I gotta go back, switch master. There you go. We deleted that. No longer, so if I do a git branch, there's just master. So it's a workflow, right? Create a branch, do your work, merge back to main. Okay, I think that's it for Git. So now, how much time we have?
20 minutes?
Okay, so we can do a little tour of GitHub. Okay. Because so far, I think this is a really cool tool and I mean, really essential tool for computational research. However, we need the way now to collaborate because this was all local. This was all me and myself. So how can I, first of all, very importantly, have a backup of my code? What if my computer breaks? So you want to have that hosted somewhere, right? GitHub offers that and also offers the possibility of collaborating because people can see your code, they can contribute to your code and all of that. So I am going to go right here. This is GitHub. This is my GitHub page. Your this is
so good. Yeah, you spent a lot of effort on this.
well,
This is great.
I was looking for a job, so, you gotta have a good looking GitHub. So that's it. And there are ways to do this, but the important thing here, you have repositories, right? And I have this Git demo here that I created for this, but I'm gonna create one from scratch. I'm gonna delete this. I should have done this before.
I would $50 minimum. I may need you to.
There's a lot of safety involved in it, which is very reasonable.
Yeah, they don't want you to delete.
They don't want you to delete things that you don't want, so I'm just confirming here on my mobile. Boom, it's deleted. Okay, so we can start from a clean slate. So what I'm gonna do, I'm gonna create a new repository, and that's gonna be where the code's gonna be hosted. And I'm gonna give it the same name. I don't think it matters if you give it the same name or not, but just to be safe, let's do that. So it's Git demo. Okay. Now, this is important. I'm not going to add anything. Why I'm not going to add anything? Because that's going to give, if you add something, then you're going to have a different history. Then what you've done here already has a different history than what you have locally. So putting the two together is not impossible, but it's kind of out of the scope of what we want to do here. So I'm going to create a really clean GitHub repo that has nothing. Okay, so create repository. There you go. It's a clean. There's nothing. There's no history. There's nothing. So that's perfect because that's what we want. And you actually have instructions here on what you got to do. So we're going to go ahead and really do this to the repository local. Okay. So the first one, we're going to add a remote because, okay, let me just show you something. I have all this work that I've done locally, and how you push that is really a command called git push. Okay, and if you try to do it right now, it's not going to work because Git is like, well, I have no way to guess where you want me to put this. So you got to tell me. So that's what that command is doing. This one right here, git remote. So this is the remote repository add. Origin will be sort of the name of the address that you can choose whatever you want. This is just the standard practice. And then you put the address of the GitHub repository. Okay, so that's what we're doing here. We add the repository. Boom. Okay. One way to check if it worked is git remote -v. It gives you a list of origin of where it's connected remote. Now we're not done because unfortunately by default Git creates branches. The main branch in Git is called master, and the main branch in GitHub is called main. I'm not going to get into why because it's silly. It's incredibly silly, but it is what it is. So we got to run this command to rename our local master to main. Okay, so that's what we're going to do. That's what the command is doing. It's basically telling you git branch rename main. So where I am, it's going to be called main right now. Okay, and we can see git branch. What happened? There we go, main right there. So now it's no longer master, it's main. So that's Good, because we want it to match. And now we're going to do this command here. Typically, you only need to do git push. But since it's the first time and you want to make sure all the links are nicely, put together, you do a -u origin main that basically tells the repository from now on, this branch needs to look to this cloud repository. Okay, so he kind of finishes up putting all the links together. But typically you only need to do git push. Okay, the normal routine is git push. Okay, so hopefully that will work. That will work. Okay, so I pushed all the stuff that we did together here, should be available online. So let's refresh the page. There you go. So my files are there. So I'm connected. Okay. So it's again a nice way. Now anyone, because I created it public, I should say somewhere, where is it? Public, right here. Anyone can see this. Now, it's up to you to decide if that's what you want. Like my postdoc advisor did not want anything to be public until we publish the paper. Once we submit the paper, we will make it public. But before, yeah, he was a little bit paranoid. He thought no one's gonna look at my code. I promised him that. But once we submitted the paper, we would publish all the code, and it would be available for anyone to see it. So this is how you in the configuration is that there's a lot here, and we don't have time to cover everything, but you can have a lot of setup and how your GitHub page will work. All right, so let's do the reverse now, because what we did is we pushed local stuff to the repository, but what if there's some modification that happens here? How do we get that to our local? Because maybe someone else come here and do some work, and I want to fetch that work. Okay, so how I'm gonna just add a README. A README is a really nice file to have for any repository, because not only it has the very basic summary of what the code is about with instructions, it also kind of works as the front page of your code. So, and it's Markdown. If you're familiar with Markdown, you could say lunch and learn, and then you can use all the hello. Okay, so I'm going to commit, and also gives you several options on how to do this. One is new branch. You can create a new branch and add this to a new branch, which is probably the best way to do those things. Okay, but since again, you don't have to overcomplicate things at an early stage. If you're just starting work on a project and it's just you, there's no reason to complicate things. Just commit directly to it. Okay, but eventually when things get in a certain stage, you need to start taking precautions on how you modify it. And that would be creating new branch should always be the standard. Okay, so I'm going to commit this directly. It's going to go directly, and see how the page here. By the way, the address of the page is also very convenient, because it's just GitHub. It's my username, and then it's you don't need actually all of this. It's just git demo, the name of the repository. We'll take you right here. And that README, look, it works as a welcome page. You can put an image here. Let me just show you, just for the sake of the possibilities that you have. So this is something I did as a PhD student, right? So you can have a lot of information here on the front page. They'll tell you sort of the publication that I want people to refer to if they use this, a basic how to use blah blah blah, all the stuff. So yeah, so it's the README is a really nice tool to have a good looking GitHub. All right, so all right, how do I get this? There's another command. It's git pull. There you go. So we go here to files. That's exactly the file that I created over there. So this could have been someone else working on this project, right? And you really want, so as a good practice, before you push, you always want to pull to make sure you don't generate any conflicts or things don't get, the wires don't get crossed. Okay, so whenever you do a new modification, so I'm going to modify this and put some additional info. All right, and then save this, git add git commit improved readme. And then you want, again, even if there's nothing new there, I'm just for good practice, you must git pull and then you git push. Okay. All right. What else? If we create a branch, git switch new stuff. I think it's a C. Okay. All right, let's just add some other stuff there. Other stuff. Because I'm going to show you now pull requests. First of all, let me just refresh this and the README should change. See, those are connected immediately. And now I'm going to git. So I'm on a new branch, correct? I added even more stuff. So I'm going to git add. Again, this workflow will be hardwired in your brain. Git commit even newer stuff. And by the way, this is very important, this message. Right here, I don't have much to write, but you should try to be as descriptive as possible. And then git push, which it's probably not going to work, right? Because we need to actually tell the system, hey, you need to git push. I think this should work. Let's see. Origin new stuff. There we go. So basically, I did a git push, but I said, remember that -u helps making the first connection. So the origin is the remote that I added before, and I'm just telling it to create a new branch. And exactly what it did here, you should have created a new branch. Where is it? Right here, new branch. Okay, so let's go to the online interface and see what's gonna. Oh yeah, it already detected. See, new stuff. You have a new branch. Okay, and how you can change the branches right here. Wait, one branch right here. Main new stuff. Should say right here. Yeah, right here. See, the two branches are right here. So now the proper workflow, how are you going to merge that back? You would do this. You will compare and pull request. And the best way to do pull requests is really, I think, through GitHub. It's the best interface. So you get this nice interface here that's telling you, hey, I want to bring this stuff on the new stuff. What we did locally, I'm just doing online. But here you can put a title, say, new feature, you know, or you put a title to it and you explain at length what is going on. Okay, and then you create a pull request. That will not merge automatically with your code. Okay, so if we go back to the code, it's still the same one. Look, there's not the new line I added here. But right here, there's a pull request. Okay, if you are the administrator, if you're the person managing the repository, then you can go here and decide whether you want to merge this or not. And that's the GitHub workflow. You make modifications, you submit a pull request. Okay, and then the person can come here and merge. Of course, I created and I'm gonna merge, so it's a very but typically you can set up such that people have to review this to accept the modification, and then the modification go live.
Before the version, could you please show alternative version
If it,
on the right side of the merge pull request?
I'm sorry?
In the green button, merge pull request, there is alternative options. If you
The merge pull, the green
You mean
arrow,
this?
yes.
Yeah.
And usually people use squash and merge,
Mm.
and it allows to squash all history of your request in your branch. For example, you created your branch on Monday and made 5 or 10 commits in
Mhm.
your branch,
Mhm.
and on Friday you decided it's okay, and I need to mention the main branch.
Mhm.
And usually people don't interested about history during this week, and Git allows squash all requests into one.
So it shows us one commit. Is that what it happens?
Yes, be like one new commit which accumulates all your history in one.
Mm. Okay. Yeah, I never used this, so I didn't know. So there's always something new. Yeah, the GitHub offers a lot of like functionality on top of Git. So, but anyways, I think I'm gonna end the talk here. Merging this pull request so we get a new feature. But again, there are other things that I didn't mention. One of them, which is also important, is forks. And forks are really, if you want, so on GitHub, so let me hide this so I can show you just something. GitHub is an amazing platform that you can find like code for everything really. And a lot of them are open source. And so for example, one that I actually used a lot is this one. It's called Sci4. It's a quantum chemistry engine. So you can run calculations. It's free. Anyone can use. It has many functionalities that we pay for in Gaussian, for example, but they're here. If you want, you can come here and fork this. Look, there's 491 forks, meaning that when I fork this, GitHub will make a copy of this entire code base for me. And it belongs to me. I have all power over it. I can modify everything if I want to. I can create this is Sci4. I can create Sci5 on top of it. Okay. Of course, this is GitHub. You got to read their license and see if you're not going to get legal issues for doing that. But a lot of these codes allow you. They will allow you. They say you want to take this code, tailor for whatever you need to do. Yeah, go ahead. You just need a fork. So fork is a way that you get a copy of the code that you have total authority over. So it's your code, you can do whatever you want. And you can also contribute through forks because you can create pull requests from your forked code back into the main code. So it's a way that people do open source collaborations. So we have it here, and then people will create a fork, and then it's going to get merged, right? That happens to my code that I showed before. Let me show you the repository. So you come here, or this one is actually a better example. So this is another code to handle some mathematics of quantum chemistry. So I wrote this code, and there's no pull requests now because I merged the null. But if we yeah, this is the main one. This is a fork. So see, there's pull requests. For example, this is not me. I never met this guy in my entire life. He just found my code and he said, yeah, there's something fishy here. I'll fix it for you. Don't worry about it. And then he created this pull request, right? Which I have to merge, but I need to fix something because
Lucas.
you know him, right?
Lucas Weber.
Yeah.
Yeah. He works at Fire.
Yeah.
Oh my gosh, that's so funny.
Yeah. So he submitted a few pull requests for my code. And I need to, it's because there's some issue with it's an upstream issue, but I need to fix that. Unfortunately, I haven't had time. So, but you can see it's someone that I never met and we're collaborating, right? So GitHub is an amazing platform and everyone should use it.